Okay, we just covered compound angle formulas, and now we're just going to do double angle formula. And compound was, you know, we've got the sine of x plus y and that sort of thing. What we've got now is we want to know what sine of 2x is. If we know that sine of x, what's the, you know, double that angle with it, and we're just substituting in y is equal to x here. X plus x is 2x, and so we get formulas for that. And again, I won't bother writing down the formulas. They're on your formula sheet. I'm staring at them right now. And so this is just how we double angles and find different values. So I'm just going to jump straight into some examples here. These are quite fun. Fun, I hear you cry? Never. Okay, but here we go. Example. So if cos x is equal to 0.8 for x in 3 pi on 2 to 2 pi in that range, then find cos 2x. Okay. Now we have actually 3 different formulas for cos 2x. You'll get used to these, but cos 2x, I'll write them all down so we can just have a look. Cos 2x is equal to cos squared x minus sine squared x. It's also equal to 2 cos squared x minus 1. And it's also equal to 1 minus 2 sine squared x. So at this point you need to choose which one is best. We know cos x. We could, so if we wanted to use this first formula, we could go and find, well, we know that's fine, but sine would need to go and find sine, and that would take a little bit of work. Not too much work, but that would take a little bit of time. This one here only contains cos, which is great. We already know what cos x is. This actually looks like a very, very simple option, so I'm just going to put a nice square around that. And this one here, we don't know sine. Again, we'd need to go and find sine. So just use the appropriate formula here. So what we're going to do is cos 2x equals, we're going to use this one here, 2 cos squared x minus 1. And this means 2 cos x squared. So now cos x was equal to 0.8 squared minus 1. How easy is this? It shows a really easy example. So 0.8 squared is 8/10 squared, which is 64 1/100ths. And so that's 0.64 times 2, doing a bit of mental, 1.28. I hope that's right, everyone. 64 1/100ths, 0.64 times 2, yep, that's all good, minus 1, equals 0.28. So there's your value for cos 2x. Hope I didn't make a mistake. Okay, it's that simple. So let's just have a look at maybe a bit more of a complex example here. Another example. Find the exact value of, what do we say, tan, I'll do tan pi over 8. Okay, right, tan of pi over 8. Now we're going to use the double angle formula this time, but we're actually going to use it the other way around, and we're actually going to use it as a half angle formula. Okay, and you'll see what I mean in a second to be able to use this. The reason I know this is because I'm looking at pi over 8, and like we did for using the compound value formula, I know that this pi over 8 is half of pi over 4. And pi over 4, tan of pi over 4 is really simple. It's equal to 1. And so that's a really simple thing to evaluate. So just let me write down first our tan formula. Tan 2x is equal to 2 tan x over 1 minus tan squared x. Sorry, I forgot to say in quadrant 1. Just gotta, oh, it becomes impossible. Tan 2x, okay, so there's our double formula. So therefore, what we know is that if we say that x is equal to pi on 8, then what we've got is tan, 2 times pi on 8 is pi on 4, equals 2 tan, we said x was pi on 8, over 1 minus tan squared pi over 8. Okay, can you see how we've got this? We've got the values of x here, so x are equal to pi and 8, and over here we have a double of that. 2 times pi and 8 is pi and 4. And so that's what we've got here. Can you see why I've done that? It's because tan pi and 4 is just equal to 1. We know this value here, and we can use some little tricks over here to be able to find out what tan pi is. So what I want to do now is just to save some headaches, let y be equal to tan pi over 8. And we want to try and find what y is equal to. Okay, so let's just simplify this. Tan pi and 4 is 1. So 1 equals 2 times tan pi and 8, which is y. We said let y is that over here. Okay, and over 1 minus y squared down here. Okay, let's just solve this. This is just a quadratic. Okay, so times both sides by 1 minus y squared, and we get that. Bring everything over to that side. Actually, I'll move everything aside, but keep it positive. Y squared plus 2y minus 1 equals 0. Okay, then we can just use, can't factorise, no, it can't be factorised, and so y will be equal to negative b to plus or minus the square root of b squared. 4 minus 4, a is 1 and c is negative 1, so it's just going to be 4 plus there over 2a, which is 2. Sorry, I'm just taking a bit of time using the quadratic formula there just to solve this. And what do we get? We get negative 2 plus or minus the square root of 8 over 2. But root 8 is 2 root 2, so we get negative 1 plus or minus root 2. I hope I haven't made a mistake. Root 2. Yep, okay. So we've got this. This is our answer, but we've still got a plus or minus. We just need to figure out is it plus or minus. And y is in our first quadrant here, and so tan is positive. Where will that be positive? Well, negative 1 minus root 2, that's negative. Negative 1 plus root 2, that is positive. So it must be negative 1 plus root 2 because we are in quadrant 1. And that is your answer. Because y, I'll just write it therefore, because y was tan pi over 8 equals negative 1. So there you go. That's how we use the, instead of doubling an angle, that's how we've used the formulas to halve an angle, just going backwards.